Okay, this is a exercise from the sum and difference section, and what we have here is we have the value of sine alpha and sine beta given, but we're trying to find the exact value of sine of alpha plus beta. So let's go ahead and do that. In order to do that, we need to use the sum and difference formula. So I'm not really convinced this is something that needs to be memorized. And I'm all of a sudden panicking whether I do know that, but I think I do. So the formula is that sine alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. All right, now some of these things are given to us, like sine alpha is 7 over 25. So that's just easy enough. I just plug that in there and I'll just be done with that. And I have sine of beta is also given. That's negative 8 over 17. But in order to continue, I need to find two things. I need to find cosine beta, and I need to find cosine alpha. So it's sort of a fun problem. I mean, it's not a problem where I don't think I'm going to be doing this problem anywhere in the calculus series, the lower division calculus classes. I can't recall. But we're going to find cosine beta because I need that to fill into the space there, and I need cosine alpha. So cosine beta came first in the order from left to right, so I'm going to do that first. Okay, so I know that sine beta is equal to negative 8 over 17, and I'm going to write this in terms of right triangle trigonometry. I'm not going to look at the unit circle, I don't think. So when I do this, I am going to sort of maybe cheat a little and I mean, if we want to be more precise, this is the reference angle. And so opposite over hypotenuse makes 8 over 17. And this guy, say called A, I have to figure out. Now, this guy here is a Pythagorean triple. And oops, I sort of hesitated, so that's why it got stuck. So I think that 17 times 17 is 289. And there we go. And that is a triple. Okay, so I picked it so it'd come out sort of, nicely like that. So that's A is 15. And because of that, so I used the Pythagorean theorem, right? So because of that, I can then find the cosine beta is adjacent over hypotenuse. And so that will be 15 over 17. But there's more to it. Beta is in quadrant 2. And no, it doesn't say that. It says right in front of me that it's not in quadrant 2, in quadrant 3. So cosine beta is negative. So that's the reference angle is negative 5 over 17, but the cosine beta has to be adjusted to be negative because of the quadrant in which it lies. Okay, I get that answer. And I don't know, maybe I'll just try to get some little fun color here. I get that answer, and I take that, and there it goes up inside there. Okay, so that's going to be negative 5 over 15 over 17. I get the concept, but I have a feeling that in the end, when I multiply this out, this is going to be a little bit of trouble. Okay, over here, I'm going to find cosine alpha, what we have is that we have that sine alpha is equal to 7 over 25. Alpha is in quadrant 2. Okay. So I'm going to write this as a triangle again. Here's 7. Here's 25. And if I have this is a squared plus 7 squared is 25 squared. So a squared plus 49 is equal to 625. And then a squared is equal to 576. And that is also a it's also a Pythagorean triple. Okay, the thing is I might just break down and use a calculator, but that is, I believe, 24. I mean, of course I can do it by hand too. So yeah, that's 24. So let me put a bright color here. This is, actually, same one. This is 24. So back to this, then apparently then cosine alpha is I'm going to move this down here. I have that ability to do that. So so cosine, this is alpha reference. Cosine alpha reference is adjacent over hypotenuse, and that's going to be 24 over 25. But then if I adjust this, alpha is in quadrant 2, so it should be negative. So that's going to go there. I would say that's sort of a big number to just do by hand. I mean, maybe it's not that bad, but I mean, definitely I can do it, I think. So 7 times... 8 times 4 is 32, carry that, so it's 192. Well, 17 times 25 is a little bit, I can do that too, I guess. Isn't that 425? The thing is, oops. The thing is, if I get it wrong, I have to do a whole new video. And then, which I don't really want to do. So I don't want to do a new video because I just got that one multiplication problem wrong. Okay, but it seems that's the answer. Could be. The ideas are all right. So, okay, I see that there's some little things that went wrong with what I was writing here. So I need to fix those. Okay, actually we're almost done. We did all the hard work, in fact. Or I did, but you did the hard work of listening. Okay, so now we just need to follow up with the formula for cosine alpha plus beta. That formula is cosine alpha, cosine beta minus sine alpha, sine beta. And then we just put all these things in there, which we already have. We already have cosine alpha somewhere. Negative 24 over 25. Cosine beta is somewhere. That's negative 15 over 17. Minus. So you look up those formulas somewhere. on notes and so forth. Sine alpha is given, that's 7 over 25. And sine beta is given, that's negative 8 over 17. Okay, the denominator was already determined, 17 times 25 is 425. Then for the numerator, 24 times 15, could try to do that in my head. I think it's 3,600. Okay, hold on. I mean, I don't have to do it in my head. I can do it on the side of 360. I can do it on the side of the paper. But it sort of slows things down anyway. Plus 56. So that makes 416 over 425. Well, no, I don't think that reduces. Okay. And I don't think either the other one reduced either. Okay, no, it shouldn't. Okay, here's an interesting question. Which quadrant does alpha plus beta lie? Well, cosine alpha plus beta is positive. Sine alpha plus beta is positive. Therefore, alpha plus beta lies in quadrant 1. All right, the idea is right. I'm concerned that I added some numbers wrong or something like that, but definitely the concepts were there. So also, did I get the quadrants right? Or it seems like it's good. Okay, so therefore I'm going to declare victory and stop there.